Okay, continuing with properties of exponents in this video. As I said last time, we're going to be looking at powers of powers. So what happens when we have something with an exponent, and then we put that whole term to another exponent. So here we have x squared cubed. So to understand what this is, let's just simplify it out. We have x squared times x squared times x squared. So now we've turned this into what we did in the last video, which is just multiplying with exponents. So what we do is we add the exponents. 2 plus 2 plus 2 is 6. So we will have x to the 6th. And what you'll notice is that 2 times 3 equals 6. So what we see here is that when we have a power of a power, what we can do is multiply them together. So a way to remember this is it's always one step down. And what I mean by that is if you're multiplying the terms, you add the exponents. If you are doing a power of a power, then you are multiplying. So it's always, if you think of it in the order of addition, multiplication, powers, it's always one step below what you're doing to the terms is what you do to the exponents. So now we're going to look where we have two terms being multiplied together. And we're going to put this whole thing to the 4th power. So just like in the last video, what we do is we just treat each term separately and distribute the 4 to each one. So we multiply this 3 by 4 to get x to the 12th times y to the 2 times 4 is y to the 8th. And now also similar to last time, we're going to have a term on the outside and then something in the inside that is being put to a power. So let's see if we can do this in one step. So let's look at what's inside the parentheses first. This whole thing's being put to the 4th power, so we multiply each exponent by 4, and we'll get x to the 12th here. And we're multiplying x to the 12th times x squared. When we're multiplying, we add them. So we have x to the 12 plus 2, which is x to the 14th, times y to the 2 times 4, that's y to the 8th, times y to the 1st, so y to the 9th. All right, now let's throw in a negative exponent, as well as a third variable. We'll bring a z in here. So again, it'll be helpful if we can do this all in one step. Going in alphabetical order, since that's how we write it out. X squared squared will be x to the 2 times 2, x to the 4th, times x to the negative 5th will be x to the 4 plus negative 5, or x to the negative 1. Then we just have a single y there, and z cubed squared is z to the 6th. So now remember that putting something to a negative exponent, multiplying by that term, is the same as dividing that term with the positive exponent. So multiplying by x to the negative 1 would be the same as dividing by x. So we can rewrite this as all of this stuff as the numerator divided by x to the 1st, or just x. All right, now let's bring in lots of different properties together. Might look a little intimidating at first, but we're just going to go one step at a time. So the first thing we can do is anything that has a negative exponent can be brought to the other side of the fraction. That way we'll have all positive exponents, and it'll just be easier to do operations with them. So here we have x to the 4th and an x to the negative 2. So if we bring this x to the negative 2 up to the top, we'll have x to the 6th. Now, next, let's bring up this whole thing and change this negative 2 exponent to a positive 2. And then don't forget about the z to the 6th. That's also up here. And now the one thing on the numerator that has a negative exponent, we're going to bring down to the denominator. Change it to a positive 3. And we already brought all of this stuff up to the top, so that's the only thing in the denominator. Next, we want to get rid of these parentheses here, so we'll distribute this 2 to everything inside. Multiply the exponents by 2. And now the only thing left to do is y to the 6th minus y to the 3rd is y to the 3rd. So we're going to get rid of the denominator, and when we do that, this is 1 times y cubed. So we'll just be left with 1. Dividing by 1 does nothing, so the denominator is going to go away. So we're going to have x to the 6th, y cubed, and then z squared times z to the 6th is z to the 8th. So there we go. We simplified this whole complicated looking thing with parentheses, negative exponents, fractions, all the way down to just a very simple expression with x, y, and z, single terms, all positive exponents. All right, let's do one more complicated example like that. So here we have 3 times all of this stuff to a power. And then we'll also have something outside the parentheses down here. And why these giant parentheses on the outside? Well, because we're going to put this whole thing to another power. So here we have powers on top of powers on top of powers. Also looks a little scary. But there are a couple different ways to approach this. What you could do is distribute this negative 3 to all of the terms separately. But that's a bit tricky because it's very easy to forget something. For example, you have to remember that 4 and x are separate terms. You have to put each one to the power of negative 3. So what I would recommend is just ignore it for now and leave everything, work on everything inside here, and then at the very end we'll put whatever's left to negative 3, since we're gonna simplify all this down so there's less to put to the negative 3 power at the end. So we'll just work on inside the giant parentheses, starting from the very inner parentheses. So keep the giant parentheses on the outside. And work on the inner parentheses in here. So we're going to square everything. Negative 2 squared is positive 4. X cubed squared is x to the 6th. Y to the negative 2 squared is y to the negative 4. Be careful when you multiply. Negative times positive remains negative. Now on the bottom here we have 4x, and then just multiply all this stuff by 2. And everything in here is to the negative 3. Okay, now, if you ignore these inner parentheses, which really don't need to be there now, you can see that we have the same format, with the exception of this z here. We have constants, we have x's and y's on the top and the bottom. So that means we can start canceling stuff out. So first, just look at the constants. We have 3 times 4 is 12. Divided by 4, that's going to leave 3 in the numerator and nothing in the denominator. So we just have 3 up here. Or you can look at it as we just canceled out these 4's And there's the 3 right there. Now we have x to the 6th over x. That's going to be x to the 5th. Now, what we could do is move these negative exponents, switch places with them. But if we're careful, we can also just remember the exact property is that you simply subtract the denominator's exponent from the numerator's exponent. So he will have negative 4 minus negative 2 is negative 4 plus 2, which is negative 2 in the numerator. If we move it to the denominator, it's positive 2. So we'll have y to the positive 2 in the denominator. And now we also have this z to the 10th in the denominator. And everything still to the negative 3. So at this point, we have to deal with this negative 3 over here. So, but there's a lot less inside here than when we first started, so it's not going to be too hard. 3 to the negative 3. Actually, the first thing we should do, since it's a negative power, is just switch the entire numerator and denominator. So flip everything around, and when we flip it, we change the negative exponent to a positive exponent. And now, just multiply everything in here, the exponents by 3. So we will have y to the 6th, z to the 30, over 3 cubed is 27, so over 27x to the 15th. Okay, and for this final problem, we're going to make this pretty crazy. So if you can do something like this, you definitely understand all of your exponent rules very well. We're going to have tons of parentheses. Okay, there is the problem. The first question is, of course, where do we start? Well, we could do what we did with the last one, which is ignore the very outer set of parentheses and then just square everything at the end. But it might get annoying having to keep writing all these double parentheses. So why don't we do a different method, which is start by distributing this outer 2 to everything. So what that's going to do is it's going to lead to this fractional term over here being squared, and this term over here being put to the 4th power since we multiply these exponents. So let's write that out. So we will have this first fractional term squared times this second fractional term to the 4th. Now, let's distribute, well actually, we could distribute everything or we can start canceling out. I think it might be easier to distribute because we have negative exponents here that we have to deal with. So let's just distribute this 2 and get that out of the way. Multiply all the exponents by 2. And now multiply everything here. Multiply all the exponents by 4. So we'll have 2 to the 4th is 16. Multiply those out. And then we can do here is we have this whole term inside the parentheses. The 4 multiplies just by the outer exponent to get negative 8. You don't distribute the 4 to everything inside the parentheses. Anything inside the parentheses you can basically treat as a single term. And so the 4 only multiplies by what's the exponent already being applied to this inner term that basically just stays what it is until it's only applying directly to this directly outer exponent. Okay, now, where do we go from here? Well, we have two fractions being multiplied together. So if you look at it that way, we can just multiply these two big numerators together and these two big denominators together. So we'll start combining the terms that are the same. And so the 16 is the only constant in either of these numerators, but now we can multiply x to the 6th times x to the 16th. Y to the 32 times y to the negative 4. And now down here, we have x squared. Where's our other x? It's inside here. X to the negative 3 to the negative 8. So we multiply these two exponents together and get x to the positive 24 times x squared. We add the exponents, so we'll get x to the 26th. And then we only have one y term, one z term. And then we have this 6 to the negative 8th. You know, I didn't realize that was going to be such a big number. We'd probably need a calculator or else it would take forever to multiply all that out. So let's just leave it like that for now. 6 to the negative 8th. And now we just have to cancel out the same terms. So 22 minus 26 will be negative 4. So that means we will have positive 4 exponent of x in the denominator. Then 28 minus 6 is positive 22. So, you know what? Let's just write it like this for now. You know, we'll do the numbers first. We have 16 up here. 6 to the negative 8th down here. Actually, we can move the 6 to the 8th. We can move this to the top and make it 6 to the positive 8. So let's do that. We'll have it looks a little neater usually if you you put anything that needs to be in parentheses. Actually, sorry, that doesn't apply to this problem. Okay. 6 to the negative 8 times 16. Now, look which ones are going to be negative going in the denominator and which ones will be left for the positive exponent. 22 minus 26, that's negative. So let's just deal with the positive ones first so we can fill up the numerator. So we'll have 28 minus 6 is y to the 22. That goes in the numerator. And then this is going to be negative 4. 22 minus 26, so x to the negative 4 in the numerator, or x to the positive 4 in the denominator. And now we have one more thing up in the numerator. Z to the negative 4 becomes z to the positive 4 in the numerator. So actually, let's make our x to the 4th a little more centered. There we go. A lot of effort just to make it look somewhat neat. Okay, that was a pretty crazy problem, actually, even more so than I anticipated. But if you could do something like that, that definitely shows that you know all your exponent rules, which is very important as we begin to move into factoring higher degree expressions and later graphing them.